Today we are going to program the QM1401 color card. Hello, I'm Mats from Curious Computer and let's get started. So, here we have the QM1401 program card. First we have the blue line. This is always the same blue, and this is the first significant bit, though a little bit lighter blue. And this represents the value or memory address we are going to put in the code. The green part are actually 7 bits, as you can see. Also, the lighter green is the first significant bit, and this will be our command we are going to execute. The light blue cyan bit, it is the only bit, tells the program or the computer if the blue thing is a value or a memory address. And the black part is don't touch it. It is a counter which just represents where in the program is in the card. Now we are in the Mats QM1401 spreadsheet, as you can see down here. I linked this in the description. We can see all the commands which exist in the QM1401, also with the assembler codes, and the last says if it's implemented yet or not. We can see some of them are orange because they are not on the computer, because I planned it but not implemented because it overcomplicates everything. So we can now see the binary value we can put in the card and what it does. So we're gonna do a simple add program which adds two numbers together. So we can see load A loads memory address or value. It depends on the last bit, on the cyan bit, into register A. So we are going to go into ScrapMechanic, and then we just go to address 1 and plonk a white dot here. So that is now the command 0001 load A. What we also gonna do, we could paint that white, then it's a memory address, but we don't want that currently. We just want to add 10. Okay, I did something wrong here. So we do add 10. Then we go back to the board. Now we want to load into register B, which is one more. So we're gonna go into load into B, which does we are gonna load in 15. Then we go back. Now we want to add these together. So as you can see, you have to add A and add B. Add A just adds the two registers together and stores the result into register A and B in the B. It is actually also really important that you make it the right way when you want to subtract, because subtract A is A minus B and subtract B is B minus A. This is important, but we only want to add now. So we're gonna add. We can leave this blank, and then we have the value. Technically it is done now, so we can make our program a little bit interesting. Then we put our final thing in. So the last strip I done is really important, because if you don't do this, it just reads the whole card, and this is very slow. So you put in the last strip, and the program knows, oh, here I am, and I have to stop. So it only reads the program and then stops. And also, due to the fact we only have 64 bytes of memory, it would actually overflow as soon as it gets to here. So be careful and don't forget the stripe, because it would crash the computer every time we want to start it. So then the last thing we have to do is remove that red block, and now the card is floating and we can actually use it to do stuff. Now we have to turn on the computer as we do always. Wait for the lights, go on, and then just start it and hope it works. And on your version, make sure you have loaded in paper for the printer to read, because if not, it will refuse to work. So I haven't known that, but yeah, make sure it works. So we will start it again, and now I want to see it working. So I see 1A, which loads 1 into A, then 2F, which loads F into B, which is 10 plus 15, then 30, which should add these together, which makes 19, which is also really fine. As we can see, the program fully worked. So I'm happy with the result. It also crashed at the end. At the end, I was just tired because the video took 40 minutes or something. I had many bugs in the computer and I haven't found a problem because, but at the end it worked, and the program crashed randomly. That was because a wrong jump instruction, but that's also fixed in the final version. And if you liked the video, like and subscribe, and we'll see you next time. Bye.